Hi, it's MP, the tutor here, and today we're going to look at linear simultaneous equations. And with this, there are kind of two methods. There's method one, where you get one of the variables to be the same, and then subtract one formula from the other. Or there's method two, which is to rearrange one of the formulas to make a variable the subject, and then substitute that into the other formula. So let's look at this first method, to get one of the variables to be the same and then subtract one formula from another. Well, what that means is basically we look at our variables. We've got 2x and 5y, 3x and 2y. And what we need to do is basically make one of them the same. Now, typically we might make x the same, and we can do that basically by multiplying the first top of the thing by 3 and then multiply the second one by 2. So I'm going to call this A and this B. So A, if I multiply that by 3, I've got 2x times 3 is 6x. 5y times 3 is 15y. And then 23 times 3 is 69. If I then have B and I multiply that one by 2, that means I get then 6x plus 4y and 18 times 2 is 36. Then what we do is we subtract B from A, or the top minus the bottom. So 6x minus 6x is 0. And here we have 15y minus 4y is 11y. And then that equals, well, 69 minus 36 is 33. So 11y equals 33. So we're going to divide both sides by 11. So that means that y equals 3. Then we choose one of our formulas to plug in our value for y. It doesn't really matter which one we choose. I'm going to choose this one here. My 3x plus 2y equals 18. Or 3x plus 2 lots of 3 equals 18. 2 times 3 is 6. So 3x plus 6 equals 18. I'm going to take away the 6, so we get 3x equals 12, and that means that x equals 4 by dividing both sides by 3. So that gets our two answers. Y is 3 and x is 4. So what we're doing is we make one of our variables the same, we subtract one from the other. That will get rid of one of our variables. So in this case, it got rid of x's. And then you then replace it back in. So you work them out and place it in. And then you get y is 3 and you plug it back into the formula. Let's have a little look at this next one. So here we have 4x plus 3y is 26, and 2x minus y equals 8. Now what we can do here is we can just multiply the bottom one by 2, and that then gets our x's the same. So I'm just going to rewrite the top one, 4x plus 3y equals 26, but then I'm just going to multiply the bottom by 2 to get my 4x minus 2y equals 16. And then we're going to subtract one from the other. So 4x minus 4x is 0. 3y minus 2y, which actually makes it plus. So you have 3y plus 2y is 5y. When you have 26 minus 16 is 10. So then we have 5y equals 10. We divide both sides by 5. We get y equal 2. I'm then going to plug that into our formula, which I put a little star next to. So you have 2x minus y equals 8, or 2x minus 2 equals 8. I'm going to plus 2 to both sides to get rid of this minus 2. So that gets you 2x equals 10. And then we divide by 2 so that you get x equals 5, and that's our answer. So I'm going to circle in red our two answers for y and for x. So this is method 1. It tends to be quite an easy way to sort of get rid of things at times, but that's only if it's laid out nicely. The numbers can get a bit big. Let's have a little look at this second method, and that's to rearrange one formula to make a variable the subject and then substitute that into the other formula. So what I'm going to do is I'm going to look at the very first formula here. This 2x plus y equals 7. Now we can make any of our values subject, which means getting it on its own, but I'm going to get y on its own. I'm going to do that by just taking away 2x from both sides. So we end up with y equals 7 minus 2x. What we also then have is you have the other formula. So you have 3x plus 4y equals 18. And what we're going to do is we're going to replace the y with this y, which I'm highlighting here. So that 4y becomes 4 lots of the 7 minus 2x. So we end up with 3x plus 4 lots of 7 minus 2x equals 18. Now we're going to expand that out. You could use the grid way, or however you like. So if you went grid, you went 4 and 7 minus 2x. 7 times 4 is 28. 4 times minus 2x is minus 8x. So we end up with 3x plus 28 minus 8x equals 18. Then I'm going to make it slightly group the x's together. So we end up with minus 5x plus 28 equals 18. What I can do is put the 5x on the other side. So you get 28 equals 5x plus 18. And I've done that by just adding 5x. And then I'm going to take away 18 from both sides. Take away 18, so you get 10 equals 5x. And therefore you divide both sides by 5. So you get 2 equals x. What we then can do is go back to our y equals 7 minus 2x. Well, if x is 2, that means that y equals 7 minus 2 lots of 2, 2 times 2, or y is 7 minus 4, which is 3. So we have x equals 2 and y equals 3. So let's look at this next one. So here we have x minus 3y divided by 5, or over 5, equals 2, and 3x plus 2y minus 8 equals 0. Well, the very first thing I'm going to do is kind of sort out this fraction. So this first one, we have x minus 3y over 5 equals 2. What we're going to do is we're going to get rid of the divide by 5 by just timesing by 5. So you times by 5 on both bits, and it would get rid of that divide by 5. So you have x minus 3y equals 2 times 5, which is 10. The next step, what I'm going to do is get rid of that minus 3y by just adding 3y plus 3y. So you get x equals 3y plus 10. What I can then do is substitute that into the second equation. So we have 3x plus 2y minus 8 equals 0. I'm then going to replace the x with our x, as in the 3y plus 10. So we have 3 lots of 3y plus 10 plus 2y minus 8 equals 0. Let's expand this out. So you have 3 times 3 is 9y. 3 times 10 is 30, plus 2y minus 8 equals 0. Well, that's 11y plus 22 equals 0. I'm going to put the 22 on the other side by taking it away. So you get 11y equals minus 22. And the final bit is then to divide by 11. So you have y equals minus 2. If they never want to work out what x is, I'm just going to replug it into x equals 3y plus 10. Well, therefore x is 3 times minus 2 plus 10. X equals therefore minus 6 plus 10, which is 4. So x equals 4 and y equals minus 2. So that again is very similar to last time, but we had to get rid of that 5 at the bottom of the fraction. Let's have a little look at this next one, which is a little bit more interesting. So here we have 2x plus 3ky equals 18 and 3x minus ky equals 5, where k is a constant. So what we've got to do is find x as part A and find k given y is 2 for part B. So let's have a go through part A. So A. Well, what we need to do is get rid of our ky's. So we're going to go down the route of the first method of basically making one of the variables the same. So we have our 2x plus 3ky equals 18, and our 3x minus ky equals 5. Now what I'm going to do is I'm going to multiply the bottom one by 3. So you end up with still 2x plus 3ky equals 18. And then I got 9x minus 3ky equals 15. And what we do now is we actually add two equations together, because 3ky plusing a minus just makes it minus, so 3ky minus 3ky would equal 0. But what we've got is 2x plus 9x is 11x, and that's plus 0. And then those two added together will get you 33. So 18 plus 15 is 33. So we have 11x equals 33. So therefore x equals 3. So that's not too bad for A. Now let's have a little look at part B. Given y equals 2, find k. Well, now we've got x, we might as well work out k by just plugging in our values. So I'm going to go for the bottom equation here, the 3x minus ky equals 5. So x equals 3 and y equals 2. All we're doing is going to plug in our values. So 3 lots of 3, so you can actually write that up, minus k lots of 2 equals 5. Well, 3 times 3 is 9, minus 2k equals 5. I'm going to put the 9 on the other side by minusing 9, minus 9. So minus 2k equals minus 4, and therefore k equals 2. By dividing both sides by minus 2, you get that 2. So that is your k is 2 for your first bit, and x is equal to 3 for our second bit. So that's about it for these linear simultaneous equations. Have a go at these questions now on the screen. Work through those. See if you can make sure you get the ones with the k, which are the ones towards the end of the exercise. And the answers are now appearing on the screen. The second method there is more useful in quadratic simultaneous equations, which is what we're going to look at next. So hopefully you've understood that a bit better, and you'll join me in looking at quadratic simultaneous equations, which is to do with x squareds and stuff like that.